Hey everyone, here we have another example that we will be finding all solutions. I did a thorough deep dive and explanation on our approach and why and yada yada in the previous example, which I will put in either the comments or the description box below. So I definitely suggest starting there and then looking at an example like this one next. So if you've already done so, let's get into it. Here we have a quadratic equation. It's already in standard form. It's already equal to 0. So we are more than pleased. So we're going to get started on this. All solutions, so that means real and imaginary solutions, irrational or rational, all good. Now, this over here allows us to see ax squared, a is 1, plus bx, b is negative 8, plus c, and c is 36, equals 0. We traditionally like to solve our polynomial or quadratic equations by trying to factor first to get started. So I'm going to look to do the AC method with grouping, which means I'm going to multiply 1 and 36. In this case, very easy. Many of us will just do something like this in our heads. We get 36. Then we're going to look through the pairs of factors, things that multiply to give us 36, to find if we have a pair of factors that will add or subtract to give me the b value. We hit the square root, so we know we're in a good spot for that. B equals negative 8. Now, if we look through these numbers, well, 3 and 12 gets us to 9 if we play it right. 9 and 4, we might be looking at a 5 or a 13 again. 6 and 6, what's that, 12 or 0? So not seeing anybody that's going to be that useful. That would tell us that this is not factorable. For those of you who straight up hate factoring, unfortunately we need to factor though, especially if you're graphing something. But in the event that you do hate to factor and you just want to not even waste your time when you're solving an equation, then you can, in this case, jump right to quadratic formula. If it's factorable, you'll get some nice answers. If it's factorable, you get a perfect square under your radical. And if it wasn't factorable, at least you saved the time in trying to see if it was factorable, right? So let's dive into our quadratic formula. I do suggest that many students, probably you if you're watching this, write the quadratic formula down every single time before you do the problem until you are, fully prepared to go off into the real world on your own, which I don't think is anytime soon. So if you're watching this, just write it down. Negative b plus and minus the square root of b squared minus 4ac all over 2a. So let's go ahead and fill in our values. Actually, how about you press pause? You try to write it down with the numbers filled in. If you're feeling confident, then maybe even try a couple steps before you press play. If you're not as confident, just try one step, use a pencil, press pause, and then press play and check it and see if you're doing okay. Stop just doing it along with me. That's like singing along with the track, right? You're not really learning the lyrics. You might not be able to do it a cappella. So let's try some a cappella math, shall we? Hopefully you've all given it a try, and let's get started. Negative b, or opposite of b, means I'm doing the opposite of negative 8, which is positive 8, plus and minus the square root of b squared. Negative 8 squared, which is really going to be the same as positive 8 squared, but here's where we'll see a difference, minus 4ac, so times 1 times 36, all over 2a, which is 2 times 1. Now, being that the quadratic formula has a 4 in it at this place over here, whatever the numbers you have are for, a and c, I do suggest perhaps, depending on what you have, you multiply these first, in this case 1 and 36. Amazing, it's just 36. Then, instead of multiplying by 4 right away, some of you might benefit from multiplying by 2 twice. So if you double 36, you get 72. And if you double the 72, you get 144. So where does that have us now? X equals 8 plus minus. And don't try to be a hero and like do 10 things at once. It's probably not going to work out, okay? 64 minus, I talk about this signage in the other video, the previous one. 36 times 1 times 4, we already said it's 144. So I'm doing 64, take away 144. Hopefully everyone can immediately recognize that when you have 64 and you take away 144, you will dip into the negative range, right? The negative zone. All over, 2 times 1 is 2. All right, now 64 minus 144, I'm going to do 144 minus 64 in my head or on on paper to show you what my head is thinking, and then I'm going to adjust the sign to be negative. So we subtract it the other way. So I'm going to do 144. Now 144 minus 64, we're going to cross over from the hundreds or 3-digit numbers into 2-digit numbers. This is where you guys mess up. Okay, so let's look at this. What if I did 144 minus 44, right, minus 20? Ah, beautiful, right? This is what should be happening in your head and not on your paper. You should be able to do it in your head. And if not, let's start practicing. 100 minus 20, and 100 minus 20 is 80. And another way to even think of this, voila, that's not what I was doing. I was doing the exact opposite of that. So boom, boom, but don't distribute it. Boom, but don't distribute it. Boom, negative 80. Voila, finished, beautiful, love it. So that right there will go inside my radical. Let's continue from, so that's sort of my sidebar. Whee, scooching around, la la la. Okay, x equals 8 plus minus the square root of negative 80. Oop, it's a little far over. All over 2. Negative 80. Let's do a full x-ray of this over here to see what's inside and what we can remove from in here. The negative is our negative 1. 80 is even. 2 definitely goes into it. 2 times what? I'm glad you asked. Times 40. 40 is even. 2 times what? 20. 20 is even. 2 times what? 10. 10 is even. 2 times what? 5. Now, maybe you think, ooh, did I lose track? Did I mess up? Well, let's find out. 5 times 2 is 10, times 2 is 20, times 2 is 40, times 2 is 80. And then the negative, voila, again. Then over 2. The negative 1 inside of our radical right there, what is that? The square root of negative 1 is the imaginary unit, I. So it's going to come out of the radical. Then it takes a pair to make a square. Again, I discussed this more in the other videos, whether it's the last one or any other video where I'm breaking down and simplifying radicals for you. X equals 8 plus minus 2 times 2 comes out, which is 4i. 4i radical 5 left inside, all over 2. Almost done. We're going to bust out the purple pretzel. Let's go. So what can I reduce in these situations here? Now this 2 reduces with both of them. It has immense power at the bottom of that pretzel, you know? So I can reduce a 2 out of everybody. 8, this is in your brain, right? 8 is 2 times 4. And this 4 right here, well, that's just 2 times 2. So if I knock a 2 out of everyone, you should know what's left behind. And the rad 5 and the I, they're just fine the way they are. Let them be, okay? X is equal to 2 imaginary solutions, which are 4 plus minus 2i square root 5 over 1. I didn't write the 1 last time. Don't write the 1. It's silly. I don't know why I wrote it. But we have 2 imaginary solutions. Imaginary solutions always come in pairs. So do our irrational solutions, meaning a situation where we maybe use quadratic formula. We have something like a radical 5 left in our answer. That's irrational. And that plus minus is the pair happening, because when we take square roots ourselves, we include both positive and negative solutions. So there you have it. I hope that you are able to do something like this on your own. If you were successful in doing it all on your own and checking your answer and you did amazing, put a thumbs up. If you think this is hard, annoying, ridiculous, or not helpful, put a thumbs down. My feelings aren't hurt. I don't care. I mean, I care, but this way you're telling me to fix something. Okay. Hope that was helping. And like I said, the other video before this one may be a little bit more helpful with some of more of the details. And the one after it should be popped up on the screen somewhere. Click that if you need more support with more examples. All right. Adios.